So let's give this one a good look. They say methyl propanoate has the following percentage composition: 54.55% carbon, 9.09% hydrogen, and 36.36% oxygen. The molar mass of the compound itself is going to be 88 grams per mole. So here they say define the term empirical formula. You know that it's the simplest whole number ratio of the elements present in a compound. So next we need to determine the empirical formula. So what is the first thing we realize? If we add all these percentages, they add up to 100%. So what are we going to do? So we tell them that in a 100-gram sample of this methyl propanoate, we are going to have 54.55 grams of carbon, 9.09 grams of hydrogen, and then 36.36 grams of oxygen, so that we can calculate the number of moles for each. Fine stuff. So we start by calculating the number of moles of carbon. We understand that it's the mass divided by the molar mass. So the mass of carbon we are given in this case, it's 54.55 grams. And this is divided by the molar mass of carbon, which is 12, straight from the periodic table. So how much does it give us if we press it into the calculator? So it's just going to be 4.54, maybe let's say to 3 decimal places, moles like that. Now next we find the number of moles of hydrogen. It's also mass divided by the molar mass. So the mass of hydrogen is going to be 9.09 grams. The molar mass is going to be 1 from the periodic table. So this means we are just going to have 9.09 moles of hydrogen like that. Then from here, we must find the number of moles of oxygen. It's still the mass divided by the molar mass like that. So the mass of oxygen is going to be 36.36 grams. And the molar mass from the periodic table, it's just going to be 16. So let's see how much we get if we put it into the calculator. So it's just going to be 2.273 moles like that. Now, after doing this, we take the number of moles of carbon, we relate them to the number of moles of hydrogen. We also relate these to the number of moles of oxygen. So the number of moles for carbon, we found it to be 4.546. And then the moles of hydrogen, it's going to be 9.09. And then the moles of oxygen will just be 2.273, like that. Then from this point, we are going to divide all of these moles by the smallest number of moles, like that. So the smallest, unfortunately, it's going to be 2.273, like that. So you divide everyone by the smallest. So let's see how much we get if we say 4.546 divided by 2.273. So here we get a solid 2, like that. What if we say 9.09 divided by 2.273? So we get 3.9999 and then 1, 2 up until that. But what is important, it's just going to be 4. Did I say 2.99? If I said that, sorry, I meant to say 3.999. like that. So we just round it up and then we get 4. Then this one, if you divide it, you are just going to get a solid 1. So what is the meaning of this? It means the empirical formula. You're going to say carbon, hydrogen, and oxygen. So all these numbers are going to be the subscripts. So meaning you're going to say you have 2 carbon atoms, and then you have 4 hydrogen atoms, then you have 1 oxygen atom there, which if you prefer, you can choose not to write the 1 there. So that's what I meant when I say all of them are going to be subscripts like that. So this is your empirical formula. You are done. The next question says, we need to determine the molecular formula. So the actual formula of the molecule, because this one is the simplified version. So how do we find the actual molecular formula? So they gave us the molar mass of the actual formula. So ours is to find the molar mass of the empirical formula so that we can find that whole number ratio. Fine. So this is how we find the molar mass of the empirical formula. So we know that we have 2 carbon atoms, but each is going to have a mass of 12. Then we have 4 hydrogen atoms, but each with a mass of 1. And this is added to 16, which is the mass of oxygen. So how much do we get if we put everything into the calculator? We are just going to get 44 grams per mole, like that. So now that we have the molar mass of the empirical formula, we need to find the whole number ratio. So we take the molar mass of the actual compound, which is 88 grams per mole. We divide this by the molar mass of the empirical formula, so which is going to be 44 like that. So if you say 88 divided by 44, you realize that the whole number ratio is just going to be 2. So what is the meaning of this? It means you multiply every element in your empirical formula by 2 so that you can get the actual molecular formula. So it means your molecular formula will just be what? Initially, we had 2 carbon atoms, but if we multiply by 2, we get 4. Initially, we had 4 hydrogen atoms, but multiplying by 2, we get 8. And then we had 1 oxygen initially, but now we are going to have 2 oxygen atoms. So this is just how you find your empirical formula. And then you are set. Set for life, by the way.